perfect at right now. Maybe aren't perfect at right now. But at least a quick, like, wait a minute, we've been doing this for like 3 different chapters over the span of like 2.5 months. We need to kind of just slow down and not just bust into a brand new chapter. And we have a way to do that because your worksheet right now, unless you guys were like cramming and writing stuff down really, really quickly, this part isn't done. I think I stopped grading at number 14. Maybe just a few of you went a little bit farther. But most of us don't have this part of the worksheet done. So homework tomorrow is to have this part of the worksheet done, which we're all going to do together right now, and then this additional 1 through 6 on basically it's a chapter review. Now, quick time out before we, well, actually, some of you guys take notes, like in your notebook, not just on your worksheet. So if you guys are looking at the directions in the 9.5b worksheet, it says using factoring, graphing, square roots, completing the square, quadratic formula. I'm going to zoom in on a really nifty table that the book gives. While I do a quick recap of the end of the grading period, people who need to do like makeup, missing work, turn it in, etc., people who are stuck on test corrections and want the full half points back today, I'm going to do a quick recap for all of those people that are like, I have missing work, late work, makeup work, I have a whole missing test that I haven't taken, etc. I'm going to talk to them for just a couple minutes, but as I do, the rest of you guys that are like, no, I'm good, I'm ready, I think my red web's, or at least I've given you everything. I didn't literally go online and type in my red web this weekend. Instead, I was doing a lot of grading of the calculus and pre-calculus homeworks. I'm updating red web tonight and tomorrow night. My deadline is Wednesday morning early. So a few of you emailed me and you were like, hey, it's not on red web yet. I know, I understand. Just do an email if you're worried or if you're concerned that your grade won't be getting on there. But then I needed to wait for your guys' corrections to come back anyway before I went back into RunWeb and put those points back in. But as I'm going to do a quick rundown of logistics for those people, guys, you can see each of these words. Read the directions for 14 through, what is it, 16, 18, 19? Thank you. For 14 through 19, it says using factoring or graphing or square roots or completing the square or quadratic formula. Here's each of those words, and quick little when it's good, when it's not. When it's good, when it's not. I want you to be looking at, because I did not tell you on 14 through 19 which method to use. I did not tell you which method. Max, I see you, but I'm answering questions in a second. 14 through 19. I did not tell you which questions go with which. We hinted at it one class. But I want you guys to look through the advantages and the disadvantages and look at problems 14 through 19 and try to do a quick little, would I do F or G, or I would do S for square roots, or C or Q. What do you think? Just put one letter by each of those numbers. What do you think, once you read this little table, what do you think would be the best way if you had to choose one of these for graphing, not for graphing, for solving each of these 6? Do you think the factoring X? Do you think trying to graph a quadratic, which some of you were working on test corrections and finding the intercepts? Do you think using a square root? Do you think completing the square? Or do you think x equals negative b plus or minus square root b squared minus 4 is equal to 2a? You have 1, 2, 3, 4, 5 different methods. I want you just for right now, just to make a guess as to which you would want to use. Use F or G or S or C or Q. Okay. For those of you guys that have makeup or missing work that you need to turn in today, you may put it on my desk, and I will promise to look at it and try to give you grades on it as long as you do. Andres, listen, a couple things for me. I need your name on it, right? Or else I can't give you a grade for it. So all the papers you turn in on my desk, make sure your name is on it, number 1. Number 2, make sure it's labeled. Meaning, if it's homework 9.4a, you have homework 9.4a on it. The nice thing is the worksheets are already labeled for you. I just need your name. So any makeup or missing work that you have to give me, you can put it on my desk back there, and I will, when I get back there, go ahead and compile it all, and then I'll look through it all. So anybody who has makeup or missing work, okay? For those of you guys that have not yet turned in your test correction, this is chapter 8b, not the one we just took. We have a couple kiddos that still need to actually do some work on the one that we just took. But for those of you guys that were here on Friday, we had an entire day to work together. You had some calculus tutors in here. I was in here. We were walking around the room trying to answer questions. If it's turned in, perfect. I will give you the 100% hopefully for doing the corrections right. Hopefully you did them right. You did them entirely. Any problem you missed, points up. And then I also, if you figured out the right answer and how to get it and showed me how to get it, I can also give you half points back, which means a 60 becomes an 80, 80 becomes a 90, a 50 becomes a 75. It could be very helpful for a lot of your test grades. But if it's not here, it's okay. Look at the side board. All test corrections are due by the end of today to be considered for the grade for the end of the grading period. Meaning by the time I leave, which will probably be something like 5-ish. Now, that doesn't mean that I won't grade any of them after today. It just means it won't help your grade out for the grading period. Does that make sense? Yeah. Okay. So I'm actually not going to, well, the test correction score, I will put it in because it will help most of your grades to have a nice 100% for doing the test corrections well. But I'm not going to give you a 0 because some of you were absent Friday. You didn't get the workday. And that's okay. I'll just leave the blank score, or the score blank for the test corrections. What most of you are gunning for is those half points back on the big test score in your grade. So if it's not in here right now, it's okay. You can come and staple it. Let's not do it during class because that's going to distract people unless we get a little bit of a work period at the end. But on your way out the door, you can staple. The stapler is right up here. There's actually a couple of staplers. You can staple. You can put it in your folder. You can pop by during lunch or second period or after school. But once again, whatever is not in this folder by the time I leave today, and I promise to be here at least until 5. And if for any reason my door is locked before 5, just throw it under the door, and it will still count. Because there's a space in the door, you can literally just throw it under. But by 5 o'clock today, whatever's not in, I just can't have it done by the end of the grading period for my deadline. Does that make sense? So those of you guys that just got it, I had you grab correction papers from the back. If you can finish it by the end of today, I will get you those half points back. If you can't, your score isn't gonna go down. I'm not gonna give you a 0 for not having it done in time. I just can't get you those half points. Unless you come talk to me, maybe on a case-by-case basis, I can give an extension here or there if you really need it, but you have to come talk to me. Because I can't allow like the whole class to be giving you lots of papers tomorrow for me to get them into the grade book by the end of the day. That's just not gonna work. All right, any quick questions on makeup, missing, or test corrections? Okay. Zoom. Max, did I answer your question? Okay, didn't have to do with the test corrections?
Who's that and one more other question I forgot? Yes, we want to print a little.
If you think of it.
Okay.
So for those of you guys down there, I don't see F's or Q's or P's or how do you want to solve the problem? Right now, 14 through 19, just pick one. Pick an F, pick a G. F for factoring using the X, G for graphing. You're not going to have to do it. Like, I'm not going to fail you if you don't know how to do it. Just what do you think would be smart? What would go nicely in an X? What looks like it might go nicely in an X? What looks like it would be easy to graph according to the corrections that you just did? The answer might be no. Graphs are kind of hard unless it's written in one of the nice forms of like the test you just took. Which of them looks like it'd be really nice to get a square root in there? Because it would make everything better. Which of them looks kind of like those complete the square problems? And then if worst comes to worst, if you don't like any of the first 4, do you know which one can solve any concept? Worst comes to worst, just put a cube on it. If you don't know anything else, put a cube. So 9.5b. You're putting a F or a G or a square root or a C. Or if worst comes to worst, if you don't like any of these 4, you can put a cube. I'm going to give you 30 more seconds to take a guess as to what you think. You can put Q's for all of them. If worst comes to worst, if you're like, well, at least I know the quadratic formula. That's okay. Put a cube on it. We're going to go through each of, well, all of them but graphing, and I'll explain why in just a second. Why not graphing? We're going to go through all the other ones except for graphing. Which means we're reviewing chapter 7. Technically chapter 8, that was some graphing. and chapter 9. 10 more seconds. What do you think is a good F? A good X method? What do you think is a good box when you see it? Worst comes first. Okay, Max, did you figure it out?
I was asking if I use calculator or something like that.
Yeah, you can do that.
Okay.
Thanks for checking. I appreciate it. Okay, I'm going to go ahead and really quickly explain why not graphing. Now, hold on. Graphing is over here, and it's not as in never. Totally, it's not as in never. Instead, let's just check it out real fast. Graphing. Remember, you just did test corrections, right? If we're trying to find the solution to a quadratic or solve for the zeros of the quadratic, some of you totally messed up those ones I gave you graphs, which was so sad because it was the easiest ones. You just had to know what to look at. What are the solutions of a quadratic? Is it the vertex or is it the intercepts? Oh, what happened? You just corrected your chapter 8B corrections, your test. What was this entire test that you guys were working on all day Friday, and so many of you have turned in already? What was this test on? Graphs. So I just asked, and specifically I was talking about these ones down here at the very bottom where I gave you the 3 graphs. And I said, use the graphs to solve. Solving with graphs. What part of the graphs were you trying to look at to answer the x equals at the bottom? Not the vertex. Those of you that put the vertex got it wrong. But you're right, a lot of people thought the vertex. What were you looking at to answer? Why was it no solution when there was a vertex? Why was that no solution? Because it didn't hit the line. What line? Which line is it supposed to hit to have solutions? The x-axis. Yeah. But you're getting there, right? It was supposed to hit the axis. It was supposed to, someone help Hannah out. It was supposed to hit the x-axis. So we were looking for x-intercepts. So how do you solve with a graph? X-intercepts. Now, this is why I don't think any of you should have put graphing as your answer or as a way of doing these equations. I want you guys to look at all 9 of these, okay? And as you're looking at all 9, let me remind you from this test that you just corrected Friday and you just turned in today. There were 2 very special forms of equations and of quadratics specifically. There was this form, or there was this form. Anybody remember the name of this one over here? Not standard. Standard is the ax squared plus bx plus c. These are quadratics. They are both x squared if you FOIL them all. Yeah, this is the one that you just did corrections on Friday over the weekend. But on the test, I don't think I actually said the form. Maybe I did. Maybe I didn't. I'll help out. H and K, do you remember what blank H and K fills in? Starts with a V.
Vertex.
Yeah. This is called vertex form because you can get the vertex of the parabola, whether it's going up or whether it's going down. You can get the vertex by stealing the H opposite sign and stealing the K. Vertex form. But wait a minute. Is the vertex the solution? Danny, what did I just answer you when you tried to say the vertex was the answer? Did I say yes or did I say no?
No.
I said no. Because sadly, the vertex isn't what we want for the solutions. What do we want for the solutions? We want this form. If we can get the intercept form, remember, P and Q shows me, now it's opposite whatever sign's up there, but P and Q shows me where the parabola hits the axis, which it could be going down or it could be going up. But either way, the intercept form is the one that I want. Now, if the equation is written like this, the graph is the way to go. It's like, I can see the intercepts, I'm done. The solutions would be, for solving, x equals P and Q. And that's exactly what these ones on the test that you just corrected were. It was looking and seeing, are there intercepts? If there are, where are they? And fill in the blank, and you're done. But guys, can you look at 14 through 19? Do any of them look like this?
No.
So this would be great for graphing. This would be perfect for graphing. Or even just having a graph is great for graphing, but none of those have graphs, and none of those are written in a nice form. So I would say graphing is not a good idea. Well, if graphing was not a good idea for probably any of them, then what are the good ideas? Well, the first two, without graphing, is factoring and square root. So if I were you right now, in those little directions right above 14 through 19, can you guys just underline the word factoring, and can you put an X just to remind yourself of an X method, right? Can you put an X to remind yourself of an X method? With square roots, can you underline that, and can you literally put a square root around it, just to remind you what a square root is? Let's pause and think about these two real quick and see if any of these would have been good for factoring or would have been good for square roots. Now, remember with factoring, we are trying to, in our X method, we are trying to find numbers that multiply. Well, first of all, factoring, hold on. We need it to be in standard form. Now, some of these are standard form, and some of them with a quick little subtraction or a quick little addition could be standard form. So just because they aren't doesn't mean it's awful, but we are trying to look for one of these where we can multiply the A times the C, A times C, and figure out how the B came about. Remember, we multiply to go up, we add to go down. Did anybody or can anybody right now look at 14 through 19 and see anyone that seems to have all three pieces? Maybe it's already in standard form, maybe you shift, but do any of these look like they might go well in an X method? Max, do you see one? Let's see. So number 18, ooh, hey, that doesn't look too bad. Let's check it out. So if we take number 18 and we take it over to the factoring category, if my computer decides to work, which it doesn't really seem to want to be doing right now. There we go. Okay. We take number 18 over into the factoring category. Just because you didn't put F doesn't mean you're wrong. It might not work. But let's check it. All right, factoring category. What will go in the top of the X, guys? 49. What will go in the bottom? Negative 14. Was Max right? Is this a good X method one?
Yes.
Yeah. Doesn't mean it's the only way, but it was a good one because what multiplies to be 49 and adds to be negative 7, right? So then some of you remember there is that shortcut when there's the 1 in front that we practiced when we came back from semester break. And the shortcut says if there's a 1 in front, we can actually go straight to the X minus 7s. We just have to be careful that we did it right. But for my box people, remember, even for the hard ones, your box, well, I should say your box works better for the hard ones. So remembering how to do the easy ones is good for factoring. You could throw in each of your pieces, the negative 7x, negative 7x, 49. Hey, it's to complete the square without even realizing it. But yeah, we do get x minus 7 and x minus 7. But wait a minute, how do we finish the problem? We're not done yet, right? Like Moses splitting the Red Sea, we set each one equal to 0. Or like intercept form, we just take the opposite of what we see. So we end up with, yeah, x equals positive 7 and positive 7. It's the same thing. And maybe just a few of you are like, isn't that x minus 7 squared and we could use a square root? You might actually be using multiple methods in this one, depending on how you solve. But the old school way would have been us taking each one and splitting them up and setting them equal to 0. The intercept way is flipping the sign and seeing it's the same number. The square root way says make it a squared and put a square root. But all of them lead you to the same answer of x equals 7. One answer. One answer. And if you want to remember why it's one answer, it's a squared equal to 0. Oh my goodness, so much math that we've covered in the last month. All reviewed in one problem. Now, that gets us through number 18, right? Not the only way, but it was probably the fastest way. It was a great X method one. Not saying there aren't any other X method ones, but can we see if there are any good square root ones? And if you need a reminder of the square root method, remember, we're trying to get, for anyone who came in, quite a few of you guys did, to get help before the test. The square root method, remember, we want to put a radical, but we can only use the radical effectively if we can put it around an entire square. If it's around an entire square, we're allowed to cancel it out. We have absolute value of whatever's inside, but what we do, algebra, what we do to one side, what do we also have to do to the other? Exact same thing, right? So then we would go ahead and we would have the square root of a number, and then the absolute value reminds us to say, uh-oh, we need to set it equal to both the positive square root as well as the negative square root. Now, guys, I'm just trying to do like a quick little recap of a whole 3-day lesson. But here's my question. Do any of these look like something we could get the squared alone pretty easily to take a square root? Which one? 19? I like the idea of 19. The problem is, if we do, I'm just going to show it real quick. If we divide both sides by 4, you're right that we get the squared alone. The only dilemma is we end up with an x, and here's the sad part, Andrew. If we put the square root here, you're right, it's going to be gorgeous on this side. And that's going to cancel out with the square. But do you see what's going to happen on the other side? Didn't the x just get trapped? See what I mean? So it was a great idea because there is a square that looks like it would get alone so quickly, so easily, so efficiently, but that x just got trapped. I have an x here and an x there. I'm in some big trouble. So I'm going to actually take that one away. Good idea, but I'm looking for another one. Is there one that's a little bit easier?
14.
Yeah, I was thinking 14. I'm not saying none of the other ones. I'm just saying I think 14 is the best square root problem. I'm going to bring 14 over here. You guys realize we're solving these ones, yeah? You're solving with me? Okay. So number 14, we make them a little bit bigger. My smartboard decides to work, which he doesn't like. Okay, number 14. How do I get that squared alone, guys? Yeah, divide both sides by 3. How do I get that squared alone? I can't or I shouldn't take a square root yet just because the squared isn't totally alone. There's a 3 in front. Let's divide by 3. When we divide by 3, what do we get? X squared is equal to 4. How do I undo a square? It's a radical. Now, some of you I know already have this done from when we did it in class, but do you see why we used a square root? It was so nice to get that squared alone. Now, hold on. I'm going to say slow it down. What am I trying to remind you of? Absolute value. Because how many answers am I supposed to get? 2. Right? Now, what is the square root of 4? Do we have that one memorized yet? 2. Right? Because it's 2 times 2. If you think about breaking it down. Perfect. But what are my 2 answers? Where do I go from here if I have an absolute value? Yeah, I split it up to be both the positive 2 or the negative 2. You guys got it?
Yeah.
You see any other ones that are super easy, though, for us just to take a square root and get straight to the x? I didn't see any. Do you remember the other one that we saw in our test just a second ago? And it was on Thursday, right? We also liked the ones that looked like this because we could do these ones pretty quickly. Remember those ones? But here's the struggle. Do you see any of those? So I think we're going to stop on the square root idea, but you guys have reviewed square roots. So we have the old factoring method with the x. We actually had a nice easy one with a 1 in front. There might be another one with an a in front, but we'll try and leave it for right now. Square roots, we got that one. So number 14 then. What's the next one in your directions? I know we skipped graphing. We kind of talked about why we skipped it. Completing the square. Okay, let's review completing the square real quick. Completing the square. Almost all of you in your head right now should have a square literally in your head, right? Okay, so let's get the square. If you haven't drawn it yet, I would underline complete the square and give yourself a visual as to what we need. Completing the square, do you guys remember that we had some sort of x squared plus some sort of x, but we were missing a third? Remember that? We were missing the c, we were missing the third, or we were trying to put in our own third. Do any of these kind of look like that form of missing or not having or having it on the other side?
16.
Yeah, I think I like 16 better than 17 just because, Max, it has the squared and the x like right next to each other. This one we'd have to rearrange it. But you're right, we could add it quick, right? Let's do this one because it's a little bit easier for right now. So number 16, let's take that into the completing the square category. Maybe you chose it that way, maybe you didn't, that's okay. Let's try and see if we can get it to be completing the square. So number 16, there we go. Can you guys start making your square and filling it in for me if you haven't yet already? We know what goes in the top left-hand box. What goes in the top left-hand? X squared. What goes in the next two, the diagonal? 4x and 4x. Now careful, are you adding or are you multiplying? Because this last one, multiplying. Good, 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 good. Now, here's the problem. Where's the 16? Not there. So what are we going to do? For quadratic formula, yeah, we minus the 3. But for complete the square, we want the 16. Add it on both sides. In algebra, you can always add stuff on both sides. So let's add it on both sides. So what would happen if we add? Now, some of you might remember I would actually put a blank to be like, oh, hey, go get the number that you want and put them in. So let's put that 16 on both sides. Now, what's really cool about completing the square? Do you remember those questions on the test? After you completed the square, what were the blanks off to the side you were still supposed to fill in? Factors. What factors come out of completing the square? A 4 comes out both ways, and then what also comes out? An x. So we have x plus 4 and x. Oh, they're always the same. That's right. We can write them as a square. And why is that good? What is this? Ooh, 3 plus 16 is 19. What does this now look like? That square root problem that I just wrote down that we didn't have, but now we do. This one would have been an awful x method. Why? Do we know the square root of 19? Why is she saying the square root of 19? Well, what's the next step in the problem? Get that radical in there. Okay, I should be seeing either phones or calculators real quick coming out because what is the square root of 19? I don't have that one memorized. I know it's 4 point something. 4.4, 4.5, 4.3. Someone help me out. Max is trying it. Someone else going to back him up. Trey's going to back him up. We square root a square. That's the awesome part of radicals. We get, slow it down, x plus 4 in absolute values. But what's that decimal? Andrew's checking it too?
4.3.
4.35?
4.25.
Cool. We'll keep it to the nearest hundredth. I know, it's weird. Sometimes we did 10, sometimes we did hundredth in homework. But wait a minute. How many answers are we supposed to have?
2.
Someone else look at 2. Hang in there. We're supposed to have 2 answers. How do we get 2 answers from this? So we have x plus 4 equals, careful, a positive 4.35. Or x plus 4 equals a negative 4.35. Remember, the absolute value says I need plus or minus of this guy. Now hold on, algebra says one quick easy step. All you have to do to both sides is, careful, it is plus 4 now. How do I get rid of it and move it to the other side? Minus 4. You guys getting it and finishing this guy off? You're right here, home stretch, and you haven't done. What are our 2 final answers for number 16? X equals, careful, not positive 8, but negative 8.35. And what's the other one? Not positive 8. What's 4 minus 4? 0.35. You see it? Good mental math in the future. Does that make sense? So what have we done? We've done 14, 16, and 18. See, I think they're trying to make it harder on us over here. Not quite as obvious. So what do you guys put for 15 and 17 and 19? Who's the one guy that we haven't practiced yet? Okay. We don't have to use him on every single one. We could have actually used him on all 6, and we didn't. Because quadratic formula says just get it into the, and Andrew, this is what you tried to do a second ago with moving the 3. It says just get any quadratic into this form, get them all on one side. And then who is your A, who is your B, who is your C, and then just think opposite. X equals opposite B. Plus or minus
Square root
of
C squared
minus 4AC all over
2A.
Who looks like a kind of clear, straightforward one to use this on? 15, yeah. Now some of you are like, I wonder if the X works. If you want to think about the X, go for it. You would want to put 24 up top and -7 in the box because we have to multiply the 3 times the 8, just reminding you of that. We're going real fast. 1 and 24, 2 and 12, 3 and 8, 4 and 6. I don't think the X method is good. If it was, it would have been so much faster. But since it's not the X method, well, I'm going to come over here and do the quadratic formula and say, whatever. I have an A, I have a B, I have a C. I'm just going to go plug it in. And if you guys beat me on this, if you do the quadratic formula a little bit ahead of me and you're just trying to kind of chill and see if you got it right, you can be looking at 17 and 19 and being like, well, I wonder how to do those. I think, well, I'll tell you, I think there are multiple options for how to do these two. Depends on what you like and what you're comfortable with. So I think my, double check, A is B. Sorry, A is B. A is 3. B is -7 and C is, so what do we have? X equals, I don't want the letter, I want the number. What goes next? X equals opposite B, +7, good. Plus or minus square root. What goes next?
B and
B squared. What's -7 times -7? -4, who?
8,
3, 8, all over 2A. Why is Isaiah saying 6? Because what is double of 3?
2 times 6.
I'm kidding. 2 times 3 is 6. PEMDAS tells me, hey, we remember this, right? PEMDAS tells me I already did my squared. What comes next? The minus or the multiply? Mm-hmm. How is this? 4 times 3 is 12. 12 times 8 is 96. Yeah, -9. Ooh. I mean, I can do my over 6. Isaiah was right, but is this good or is this bad? Because what's our calculator going to do if we try to plug in? It's no solution. We're done! You like these. No solution. We're done. Because you would have a square root of the negative. Does anyone remember that really snazzy name for the B squared minus 4AC part? And if it's negative, we say no solution. There's the D. Sounds kind of like treating someone badly based on their okay, it's like discriminate, but it's discriminant. Anyway, no solution. Okay. So 17 and 19. Well, you guys have some options, but on 19, can I just give you a hint as to what I would do? Let's see if it makes sense instead of making you guys think. What'd you guys put next to 19? What'd you think? Factoring? Completing the square? Same one for 14?
Yeah.
Yeah, 19 would have been great for 14 if only the X wasn't there. The X kind of messes this up. That's what I think Jeremy or Andrew thought too. Here's the sad thing. I think factoring is the easiest one. Because if you try to go towards a quadratic formula and getting everyone on one side by subtracting, there's not even 3 pieces. But there is a great GCF. And the great GCF says, all I have to do is Moses and the Red Sea, split them up and set them equal to 0. But that's just me, because, I mean, factoring sometimes makes longer problems a lot easier. You could have done a quadratic formula, just A would have been 4, B would have been -20, and C would have been 0. Well, unless you want to be super snazzy and factor out the 4 and move it to the other side, then A would have been 1, B would have been -5, C would have been 0. But anyway, if you do factoring, you end up pretty quickly with X equals 0 or X equals +5. You can also think of intercept form and how this would have been X minus 0, X minus 5. If you think back to graphing, that was kind of a way of looking at it. But I think factoring was the easiest one, which is weird because you guys are right. It looks so close to a good square root problem, but that X messes all up. So that leaves us with number 17. Does anybody have a way of doing that? Because we don't have a lot of time. could do quadratic formula. Wait, if we were to do quadratic formula, wouldn't we have to move everything to one side? That would make the x be added and the 8 be subtracted. What do you guys think? Is that a good x method? Negative 8 to be 1? 1 and 8 and 2 and 4. Is that a good complete the square? I mean, we could. We just have x squared, and as soon as I write 1/2 x, some of you guys are tapping out, being like, ew, gross. No, please. They're fractions. So if complete the square has fractions, what do you guys think is the only other way to go? Other than the quadratic formula. Looks almost like it would work in all the other methods. But to be honest, I think the quadratic formula is the way to go. So we're going to go ahead and say, okay, A is equal to, we're right here, 1, B is equal to 1, C is equal to negative 8, and once you know your formula really well, x is equal to negative b plus or minus square root a squared minus 4a c over 2a. So you learn how to do it really fast. 1 plus 32 is 33. All I have to do to finish is plug into my calculator what is the square root of 33 and have negative 1 plus and negative 1 minus. Woo! We got it right in time. What's your homework tonight? Take 6 problems, your own 6, from page 537, and solve it using any of the methods. Figure out which one you want to use. Ready, set, go. It's that page, Alexis, and the directions are going to be solved in the method. Section gets equal on top. Corrections on top of the top.
Actually, you know,
I'll take corrections by the end of the day.
I don't know if I'm getting all your
Do I leave this on your desk?